Hello, everyone. Good morning, good afternoon, and good evening. And thank you for joining us for this session as part of the Cloud Native Data Management Day, which is a co-located event with KubeCon US in October 2021. This session, we'll talk about how you can design your application migration solutions for that hybrid and multi-cloud deployment. So taking an application that's running on one cloud on Kubernetes and then moving it to a different cloud environment, can be public, can be private. My name is Bhavin Shah. I'm a technical marketing manager with the Cloud Native Business Unit at Pure Storage, or the Portworx BU. And to help me talk about application migration across clouds, I have with me Ryan Wallner. Ryan, you want to quickly introduce yourself?
Sure. Thanks, Bhavin. My name is Ryan Wallner. I manage the technical marketing team here within the CNBU, or the Portworx business unit, as I continue to keep calling it, at Pure Storage here. And really exciting stuff today to talk about, various cloud and hybrid cloud deployments with Kubernetes.
Awesome. So let's get started. Let's dive into it. Before we start talking about application migrations, let's set a baseline. Let's understand what we mean when we talk about a stateful application that's deployed on Kubernetes. So whenever we are talking about a containerized application or a distributed application that's running on Kubernetes, there are three things that you have to keep in mind. Like, it's not just a simple application that's running on a VM, but it is more complicated. It has Kubernetes objects that are part of the application. So you define your application using Kubernetes objects like pods, deployments, replica sets. You store your application configuration in config maps, Kubernetes secrets, and you can use additional Kubernetes objects like ingress, specify security rules using roles and role bindings. If you're using any of the databases, they might have their own operators and custom resources. So there are a lot of Kubernetes objects involved in any stateful application that's running on Kubernetes. In addition to the Kubernetes objects, you definitely have your own application configuration. So things that you like, passwords or access parameters that you store in Kubernetes secrets or config maps. And then last but certainly not the least, you have the actual application data, which is stored in persistent volumes on your Kubernetes cluster. So whenever you're thinking about an application in the Kubernetes ecosystem or the Kubernetes world, you need to think about all of these different objects. So before we talk about application migration and show you a demo around it, let's talk about a recent survey that we did, like the Pure Storage organization did, where we interviewed 500 IT professionals across US and UK who had deep understanding and were involved in the day-to-day operation of designing and managing Kubernetes clusters for their organizations. When we asked them, like, what are the requirements you have when you're running stateful applications on Kubernetes, 49% of the respondents said data mobility was a really important one, and this was like only second to like backup and restore. So data mobility is definitely one of the key requirements that organizations have today when they're deploying their apps on Kubernetes. And then I think fourth or fifth in the list at 45% was multi-cloud or multi-region support. Especially when you're deploying applications in the public cloud, you need to design them in a way that a certain availability zone outage or a region outage doesn't take down your application completely. You need to design your applications in such a way that a single AZ failure doesn't affect your uptime, and your customers can still access your application regardless of the underlying infrastructure. So those are the couple of key requirements that organizations have when they're dealing with stateful applications on Kubernetes. So let's talk about, like, why would you want to move applications between different cloud environments? The very first thing is augment capacity. So if you started with a one or two clusters in a specific region, you deployed more than anticipated number of applications, and now you're just running out of capacity. You might be hitting the quota that the public cloud provider might have inside a specific region. And you just want to make sure that a single or two Kubernetes clusters don't become like the single point of failure for your application. So you want to add more clusters and you want to move your applications between clusters for that additional capacity. Next is just blue-green test. So Kubernetes comes out with a new version. Like, it used to be like 4 new dot releases every year. Now they have reduced it down to 3 every year, but still a lot of releases to deal with. So if you are upgrading your cluster, or if you just want to test your application with the newer version of Kubernetes or Portworx, for example, you can use application migration between clusters, and the thing that we'll talk about today, to test different versions. Next is dev test. So you started with an application deployed in your development cluster or your dev cluster, and instead of having to redeploy the application in your production cluster, you just want to migrate it from your dev to your production cluster, because at the end of the day, it's Kubernetes. It should work as expected. If you have the same version of Kubernetes, if you have the same storage layer at the Kubernetes level, so dev test and promoting applications from dev to the production environment is another important use case. Next, you have lift and shift. So this is where those hybrid cloud or multi-cloud models come into the picture. Like, you started with an application running on EKS. Now you thought, okay, you want to use a specific services from Google Cloud. You want to move your application from EKS to GKE, or you started with a small cluster on-prem, but now you want to move it to the public cloud, or vice versa. You can use application migration to move your applications from on-prem to public cloud, or from one public cloud to another public cloud. And then the last one is just maintenance operations. So even though Kubernetes handles most of the upgrades non-disruptively, containers and applications, like just to be safe, you want to migrate your application before you take down a cluster or you perform any maintenance activity on that cluster. So you don't have any application downtime. So these are the 5 key use cases why organizations are looking at implementing or architecting an application migration solution between different cloud environments. So one of the solutions that we'll talk about today to help you as an administrator is Portworx PX Migrate. PX Migrate is part of an extensive portfolio of products from Portworx or from Pure Storage that help you with Kubernetes data services. So these modules include things like PX Store, which provide the storage layer for your Kubernetes cluster or for your pods. We have additional modules like PX DR and PX Backup that help with disaster recovery and data protection when it comes to applications running on Kubernetes. We have modules like PX Secure that help with authentication and authorization, and PX Autopilot, which help with automated storage capacity management for your applications running on Kubernetes cluster. And this can be running anywhere. Like, Portworx provides that unified layer or consistent layer across on-prem or public cloud. Today, we'll be talking about Portworx PX Migrate and how that helps you migrate your applications between these different cloud environments without having to do it manually. So let's talk about application migration. We already discussed what an application looks like in Kubernetes. It has the Kubernetes objects like replication sets, stateful sets, deployment objects. It has your Kubernetes configurations or application configurations stored in config maps and secrets, and you have your volumes. And again, since we're talking about Portworx, these are Portworx volume. And then you have these are parts of a single application, but then you might have multiple applications running in different namespaces on the same cluster. And as part of your migration exercise, you might not want to move all your applications from one cluster to the second cluster. You might just want to migrate a couple applications or just a single application to a new cluster. So a PX Migrate definitely helps you with that, because it identifies or it knows what a Kubernetes namespace is and helps you move all the different components that are running in a specific namespace to a different cluster. So the demo that we'll look at today is we have a simple application that's running on an OpenShift cluster in Google Cloud, and we as part of the application migration process, we want to move it to Azure. But that's the one scenario that we are demoing, but there are all kinds of permutations and combinations and all different applications that we support with PX Migrate. You can run any stateful service, any data service on your Kubernetes cluster running on Portworx, and you can be running on any flavor of Kubernetes. So you can be running on OpenShift, which is what we'll cover in this demo, but you can be running on Tanzu and you want to move to Amazon EKS, or you might be running on Azure AKS and you want to move to Google GKE. All of those scenarios are supported by PX Migrate. and that is something that you can leverage to simplify your application migration operations. So let's look at a migration spec before we pass it on to Ryan to do the demo. So you can perform migrations by just using a simple YAML file. And in this YAML file, you can configure things like the namespace, obviously, which hosts your application. You can specify a cluster pair object. So this is where you link your source and destination or primary and secondary clusters together. You can specify additional parameters like include resources. So obviously we want to move all the Kubernetes objects and application configuration, not just the data. Start applications is true because we want this to be a one-time migration. So as soon as the application is completely migrated, all the objects are copied over to the secondary site or the destination cluster. You want the application to start as soon as possible. And then you can specify, like if you want to just have one migration spec for all your different namespaces, you can have an admin cluster pair and an admin namespace that manages your migration for all different namespaces. So without further ado, that's it for the slides. Let's just hand it over to Ryan to talk about or to actually demo an application migration from one cloud to another. Ryan, it's all you now.
Sounds good. Thanks, Bhavin. So we're actually demoing using OpenShift container platform. We're running a OpenShift deployment on Google GCP, as well as a OpenShift deployment on Azure. So this terminal on your left is the GCP cluster, as you can see here. And the terminal on the right is your Azure cluster. And so these are the actual nodes in both the GCP and Azure clouds, just so you know that we are in fact running these things in those cloud environments. And we have a couple of stateful applications running in those clusters, MySQL, as well as Postgres. So this Postgres database has Postgres data mounted to a mount path in the cluster using a Portworx PVC. We can see them here using the Postgres Portworx volume storage class. So this is in fact running both stateless and stateful components, the stateful component being the Postgres database with the PVC. Here we can see that Portworx is deployed and enabled within our kube system namespace. There are a number of different containers that go into deploying Postgres, but both, Portworx, but both clusters in this case need to be running Portworx for you to have this sort of capability across clouds. We're going to be using the demo namespace. Here you can see in Azure, the demo namespace doesn't even exist. We haven't done any migrations, nothing, no pre-work, no volumes, no Portworx storage classes, but Portworx is installed. So that we can actually enable this to happen. So now we can drop into our terminals in GC and Azure. We can view the status of Portworx in both cases. We can see that both are healthy, but one is in the US East 1C and one is in West US 2, 3. So pretty different geographical locations as well, where you may want to migrate some data across for various reasons. Here is our stateless and stateful components. The KDS counter is the web application, MySQL and Postgres. And you can see here on the right, Azure doesn't have any of those. So that just confirms sort of what we're doing, what we saw on the UI. Now we're going to interact with the app by clicking on the stateless component, the web front end, and this adds 9 records to our Postgres database. So here, refreshing this front end shows all 9 records or icons in this case. We also have MySQL, which isn't part of that application, but it's just another application to show you that we can migrate multiple applications at a time within a namespace. So in this MySQL database, we can create a database called foo, in this case, and add some basic data to it, such as some pet information. And we're going to add a dog's information with the first name Roscoe. That happens to be my dog. And so now we have a record in a database, as well as 9 records in the Postgres database. So we're running 2 different stateful applications now we have in the GCE cluster. So in order for you to actually migrate anything, a cluster pair must exist. So in this case, we pre-set up the cluster pair, which pairs the GCE and Azure cluster together. Note that there is some requirements to do so, such as a secure endpoint on the destination, as well as some ports that need to be enabled. And you can do this in a secure way or over VPNs and things like that. But that cluster pair is ready to go both from a storage and scheduler status. We have a migration policy here, which shows that it's going to migrate every 15 minutes in this case, as well as monthly and weekly. So it'll do these migrations however you set that policy to. And then we have a migration schedule, which actually is the migration object, which moves volumes as well as applications to our Azure cluster. In this case, we have start applications to false and volumes to true. So basically, when we create this migration, it'll move everything, but it won't start the applications right away. Basically, it stages everything in Azure. So now we can start our migration and get the migration status by using storage.ttl, the CLI for Stork within Portworx. And we can see our status is in progress and volumes are being migrated first, and then the resources. So as this is happening, we can actually go ahead and look in our Azure namespace. Our demo namespace just showed up a few seconds ago, which shows you that the migration has actually occurred. We can see that it's successful here. So now in the UI where we didn't see any information, now we see the demo project, right? Our demo project didn't exist before. And there are our applications. So the counter piece, and note that because start applications was false, we didn't scale up. So no pods are running, but everything is ready to be run, meaning that the data is there. And the objects are there and you can turn them on. But in many cases, you may want to do this and stage them. So we're not actually running them yet. And we actually want to go ahead and sort of turn off the applications when we're ready to on this source. Now in asynchronous DR, and synchronous DR, it actually uses these underlying capabilities and will do a more a failover approach, whereas PX migrate is sort of the underlying tools that you get that you can use exactly how you're being shown here. So instead, I'm doing things a little more manual, suspending the migration status here so that the migration schedule doesn't kick off any new applications and scale everything down. So basically turn my application off in the source cluster because I've performed this migration. And I don't think we're showing it here, but this can happen across OpenShift versions or Kubernetes versions. So if you are upgrading a Kubernetes version and moving clouds, this is another way to do it. So now the applications are off. I can go to my Azure cluster and simply activate that migration in the demo cluster. So storage.ttl activate, everything scales up to what it was using before, and we have 5 pods that will become running shortly on the destination side of Azure. And we can see our applications down on the source side, and our application pods are now up and running on the Azure side. So we can quickly do this from the CLI as well to verify. Our Postgres, well, there we go. Our Postgres pod was just downloading its image probably. So now we can refresh the application on the Azure side and all of our data there. So we have database records of the original 9, and we can continue to use our application because it's fully running with its database and stateful components, as well as dive into our MySQL container here or pod, just to verify that the records we were using earlier do in fact still exist, both in the Postgres and MySQL database. So here we have our Roscoe pet here. And that sort of confirms, the data and stateless components moving from one cloud, in this case, GCE in the east region to Azure in the West region. And now we've fully done a migration of that demo namespace. Now you could do this again as a part of the overall migration capabilities with PX Migrate. And that's all I had, Bhavin. So, back to you.
Thanks, Ryan. That was a great demo. That's it for this session. Thank you so much for watching watching the session and joining us for Cloud Native Data Management Day. We have more sessions in the catalog. So if you want to learn more about not just PX Migrate, but PX Autopilot or PX Store, PX Secure, watch the other sessions as well. Until next time, thank you.